So
Now you're
hello,
on.
everybody. Welcome. Oh, I'm on now. Excellent. Welcome, everybody, to the first set of student presentations. We have two student presentations for this session. Unfortunately, our third student presenter was sick, but we have some excellent ones coming up for you. To start things off, Brian is going to be giving you a presentation on machine learning and its relation to atrial fibrillation or applications there. So Brian, I'll pass things over to you. You can share your screen and we'll be, if you have the slides, and we'll be good to go. Okay.
All right.
Looks
Perfect.
good to me.
Thank you, Alex. So, as mentioned, I'm Brian from Queens, and I'm excited to, kick off this first presentation session talking about some of the ongoing research we're doing around detecting atrial fibrillation, how to actually label it. So, without further ado, what is AFib? So, the kind of high-level explanation is that AFib is what happens when the upper chambers of the heart, the atria, aren't contracting normally. There'll be some disturbance, as you can see here, some kind of fluttering, and that can have multiple consequences, which I will go into in a second. When you actually look at a monitor, so what we call an electrocardiogram or an ECG, what you usually see on the kind of bedside in an ICU, you'll see that the kind of first part here on the left, what we call the P wave, is either corrupted, it's either not there, it's completely flat, or there's some noise in it and it doesn't have that characteristic bump. So that's when you're actually trying to interpret if somebody has AFib or not, that's what you look at. Now, why do we care about AFib at all? Well, AFib is usually present in about 2 to 3% of the population naturally, but we find that it's far more prevalent in the ICU. So the figures vary. It depends a lot based on patient population, region, and whatnot. But it can be as high as 50% or as low as 4%, which is still quite a bit higher than the general population. A ballpark estimate I've seen is around 10%. So that's kind of a good thing to keep in mind as you go through these. And the consequences of having AFib, especially for ICU patients who are already at risk, is that you see higher percentages of very dangerous conditions like stroke. So because the heart is not beating properly, you can get clots, which often migrate their way up in the brain and can cause stroke. You get sepsis as well, and general heart failure and other heart conditions related to the kind of non-functioning heart rhythm. And then general just bad outcomes for morbidity, so including length of stay, including the number of critical interventions that need to be made that are often compromises because your time is very limited in the ICU. Sometimes you have to do something that may leave long-term damage in order to ensure the patient actually lives. And we want to avoid all that. So trying to catch AFib ahead of time and try to understand how it manifests in the ICU is really vital to ensuring patient safety and patient quality of life. For this exact reason, there has been a ton of interest in analyzing electrocardiograms, which is what you saw before with that wave, and specifically also for looking at arrhythmias like atrial fibrillation. You can just see this literature review that was made very recently, and there are already hundreds of publications looking at this, especially focused on machine learning. Some of the challenges around that, though, when we try to apply that to a real-world environment, is that we have a lot of data. ECG data is really easy to collect, and it's really easy to store because it's just one signal. But we don't really know what to do with it. For example, looking at KGH, where I collaborate with, we have over 11 terabytes of signal data from the bedside monitors. But we don't have nearly as many clinicians who can actually go through in that label and say, is this AFib? Is this just a normal heartbeat? Is this something else? So the research problem we were trying to look at here is, how can we make this more efficient? How can we actually get some meaningful insight from this data and try to find AFib in it without spending millions of dollars and hiring hundreds of physicians to look through it. So the pipeline we've come up with to actually get data out in the first place is that we've pre-trained deep learning models from the literature on public data. The idea here is to have kind of a bootstrap that we can use to further label our existing data at KGH. It's not going to be perfect. It'll give us what you call weak labels, which are kind of best approximations from the model's perspective, but it gives us somewhere to start with instead of just looking through hours and hours or even weeks of ECG data and trying to pick out the best regions of interest. Once we do those, we go through and look for areas where the model thinks the rhythm type is changing. For example, so you might have 10 seconds where it thinks it's a normal beat, and then suddenly a patient will go into AFib. And we'll chunk based on those, I guess you could call them confidence splits in the class. And we'll use those to extract our contiguous segments. Then from there, what we'll do is because we can't feed just an hour of continuous AFib to a deep learning model, we'll take 10 seconds from the front of each of those. And what we've tried to do for now is take at least one segment per patient, so we have as diverse of a patient population as possible. From there, for the actual annotation, because we still do need human intervention, let me see if I can turn this up to higher quality. We developed a web application where annotators can log in. They can go through a collection of all the segments we've collected. And sorry, let me see if I can loop this. And they can choose from a set of 8 classes that we determined are things we're interested in. So this includes normal heart rhythm, this includes AFib, but it also includes a few other rhythms that don't really fit that kind of nice box that we still want to capture in case there's some insight there where they may conflict with AFib, they may look like normal rhythm. Just generally trying to get as much bang for the buck out of our annotation as possible. So you can see here on this video, it says test student. Our initial annotation is we had 2 critical care physicians from the Department of Medicine and Kingston Health Sciences Center annotate, but we plan to extend this to students as part of our ongoing work. Now, what have we found so far? So the first round of annotations we did, as I said, with 2 expert clinicians who are well-versed in ECG, especially in the ICU, and on around 600 or to 700 patients. What we found is the proportion of atrial fibrillation is close to what we expected. 14% is well within that kind of ballpark of around 10%. And there is a small proportion of non-AFib, non-normal rhythm as well. It's not shown here, just mostly for space. But for example, for those who are familiar with it, we found some pacemakers and also some different types of bradycardia. We also found, surprising, that our expert annotators had a very high agreement. So 0.81 is extremely high for this kind of annotation task. And that's really promising because it means that the segments we're extracting are pretty unambiguous in what kind of rhythm they are. We also, for interest, looked at compared against our models. So we trained 2 different models on 2 different public data sets to do our segmentation. And the agreement is kind of a mixed bag. So one of the models was only about 0.53% or 53% agreement with our human annotators. And the other one is about 0.71. And the reason we believe one of them is so low is because of how the classes are assigned. So if you go back and look at the annotator itself, you can see that there are 8 classes. But if we go here, you can see there are 3. This is one problem with medical labeling in general, is that nobody can quite agree on kind of what the different classes of rhythms are, what to label. And we believe that this other class right here that you see is a very broad class and that everybody thinks about it differently. So that could explain some of the discrepancies that we see between human and machine annotation. So moving forward, as I mentioned, this is still ongoing work, and we're still really digging into further stages of annotation and also what we can do with this annotated data once we get it out. The biggest thing we're looking forward to is getting a medical student, so getting far more annotators using this platform who are not experts with ECG, but who we've already trained and who can kind of get their hands dirty with this kind of data annotation process. We want to look at especially how well they perform compared to our expert annotators, and to see, for example, if there are certain classes they have trouble annotating, maybe because they're not common, or because they may be ambiguous with other classes, like I showed before. We also want to find bottlenecks with our actual application, because if this is successful, this is something that perhaps other medical facilities and other hospitals can make use of for annotating their own data. Looking further ahead on the analysis side, obviously we want to see quantitatively and qualitatively how AFib presents and what it looks like. Does it always look the same, or are there some variations between patients or between maybe different parts of the ICU? We also want to obviously train more machine learning models on our own data at KGH to see if we can extend that and perhaps use that for future predictive analytics as well. So with that, thank you for your time.
Go. Thank you very, very much. I hope everyone enjoyed the presentation. And if you have any questions on there, you can post them in the chat, and we'll be getting to all of those after our second presentation. So I'll give Adel a second to prepare his slides, and then we'll be ready to start the second presentation. Thank you again, Brian.
Can you see my presentation, or?
Not just yet.
Just a second, there's something. Oh, I have to quit. Just a second, I'll be back. Just a second.
Sure thing. We'll give you all a moment. There we go. That's the joys of doing everything online. Excellent stuff. Looks like you're just connecting.
Sometimes you have in the Mac, you have to turn off everything. It's confusing.
Sometimes that's the only option you got.
Yeah.
Oh, there we go. Now I can see.
Is it good? Okay.
Yeah. Wonderful stuff. So I'll stop my video and I'll give you the floor.
Okay. Hi, everyone. My name is Adel Alhejaili. I am a PhD student at the Faculty of Computer Science at Dalhousie University. I'm going to take you to a different journey. My topic is Return to the First App. It's an exploratory study on how users choose apps for the Android platform. First of all, before going to how users install app in general, we'll just define a queue. It's a piece of information provided by a medium that allows for evaluation of that information. For example, when users, for example, looking for an application that is similar to Twitter application, they can search and they will be presented with different applications. They can examine certain cues or informations, for example, the name of the application, the app logo. Once they're interested, they can go to the second stage to view more information, for example, looking at the application screenshots, considering the app reviews, reading them, looking at similar app categories. If they are interested to install the application after examining additional information, they can click on the install button to install the application, and they will be presented with permissions. However, the permissions are no longer requested after the introduction of Android 6. This leads us to how we make decisions. For example, now we can see that the amount of information faces individual is infinite, and the number of applications that Google Play Store and other stores are enormous. And from the classical perspective of the decision-making process, all of the attributes should be analyzed, scored, and weighted for all of the available options. However, this tends to be complicated and exhausting for the decision maker, especially when the number of alternatives and attributes increases. This leads us to the use of heuristics. It's a mental generalization of the knowledge based on the experience that provide shortcuts in the processing information. From the framework of fast and frugal heuristics, it's defined as a strategy that ignores parts of the information with the goal of making decision more quickly, frugally, and or accurately than more complex methods. And also from the least effort principle, which indicates that people prefer less efforts, not because they are lazy, but they are economy-minded processors who spend their cognitive resources only when they are truly needed. Heuristics in general support the people's primary objective when looking for information to find it more quickly and accurately. This leads us to that there are 3 blocks of heuristics: search role, stopping role, and decision role. The search role is when user initiate the decision of their search through cues. The stopping role is when they pose the search question and find a cue leading to the stopping role. Lastly, the decision role is when users reach their final decision to install an application. We built our work on previous studies. One of the studies is by Dogrol et al. They did an exploratory study of how users install application, and they found 5 classification of heuristics. These 4 are a variant of take the first, pure take the first, inform and take the first, confirm and take the first, inform and confirm and take the first. Lastly, the boundary alternative is a complex heuristics, not like the other ones. They were evaluated through 3 different criteria: scrolling on the application selection page, examining additional information on the application page, installing first few apps. All of these 4 share the same criteria of installing first few apps. However, the boundary alternative heuristics users usually do not install the first app they view. Also, they may or may not scroll on the application selection page to view more information or examining additional information. This led us to want to look at how we examine these heuristics that reported earlier with respect to 6 classification to more accurately describe how users choose which apps to install and which factor and cue to consider. The used classification are participant, app categories, heuristics, the level of education, time using Android, and age. We also wanted to correct some of the misconception reported by area researchers and also explore the employed heuristics by users. We did an exploratory lab study with semi-structured interview. We asked participants to install 2 applications, and also we asked them to think aloud procedure. And we were given certain scenarios to mimic the application selection process. And also we have employed many code roles like examining, for example, the scroll behavior, the number of apps seen on the application, the factors considered by participants. This tends to be a study variables for the statistical analysis and also for the app factors that we found. There were 84 instances of applications installed. Here are the factors and the cues that we have came up with. There were initially 24 factors, later merged to 17 higher level factors. For example, the blue badge is considered as a given mark by Google to the top developer in a particular field. Now it's replaced with the editor choice. Some of these factors are considered to be related to the user's search behavior. For example, I have to have a problem to download an application. Some people like avoiding ads. Some of them have known the app that they have to install beforehand. Based on all of these investigation and study variables, we came up with the research framework of how users download apps, which is an extension of the previous work. We have identified 3 different stages. When users search for a keyword, they will be presented with a few applications. In the first stage, they can consider and observe factors before selecting an app to view. They can avoid ads. They can consider, for example, the blue badge or the app rating, the name and the brand and the app logo. Once they are interested, they can move to the second stage. It's important to note that the first stage is like these cues are considered to be a starting point or just a place to start, leading to the second stage where they can examine maybe the number of downloads, reading more about the application, examining the reviews, looking at similar app categories. If they are interested, they can click on the install button and they will present it with permissions. However, we mentioned earlier that after the introduction of Android 6, permissions are no longer requested. In the current Google Play Store, once the user click on the install button, the application will be installed directly. In terms of the heuristics used, we found that 70% of our sample have employed the bounding alternative heuristics, which is considered to be complex heuristic, 70%. Confirm and take the first came second with 16.7%. With respect to the multiple use of heuristic employed by participant, we found that 57% adhere to use only one type of heuristics, 35% use multiple type of heuristics, simple and both. As you can see, the different colors denoted by explain the different type of heuristics. Investigating the different classification of heuristics and the app categories and the other variables had led us to come up with a new type of heuristic, which is return to the first chosen app, which was employed by 8% of our sample. For example, ID10 participant with ID10 start with the Smart Receipt app. He examined a few cues. Then he wanted to see other application with examining additional information and different cues. After examining and evaluation multiple apps, he came to the conclusion that the first app is the best one to download. It's important to note that some participants have employed the return to first heuristics in both apps, some of them in just on one task. We found that when participants search for apps in the Google Play Store, we did like a matrix to see which the common patterns of factors and queue. That many of participants consider a combination of factors instead of relying only on a single factor. And also we have corrected some of the misconception reported by earlier researcher. There was an assumption that first queue observed were the most important one. However, the importance was determined later. Tudorov stated that the people consider all relevant pieces of information, elaborate on these pieces of information, and form a judgment based on this elaboration. On the right, you can see that the first factors considered by a participant when looking for an application, the reviews came in the 8th place. However, when we combine all the factors, the overall percentage of the installation factors reviews came first with 57%. This shows how the reviews are an important factor. Some of the limitation, the limited pool will educated sample, tested an older use interface of Google. The current Google Play Store, they have moved some of the queues from the second stage to the first stage. They add more categorization, more tabs that people can use to serve applications. Most importantly, differentiating between heuristics is considered to be one of the most problem-facing researchers in terms of the way the heuristics are measured, because heuristics all the time are used in an informal and initiative manner without much planning or even awareness, and even hard to verbalize. For future work, we will want to look for path analysis of the factor queues, maybe use the principal component analysis to see which factor are dependent on which. Also, we want to refine our research framework, and also we want to look for what factors that are related to specific app categories. For example, we found that the name and the brand of application are most chosen or considered in the health and nutrition app categories. In conclusion, we have a better understanding of users, which will help developers. For example, users are looking for the aesthetic design of the application. They are looking for the app logo, the design of the app, screenshots of the app, the simple layout. It's going to help users to choose applications. Also, we have created a framework by identifying different stages. Also, we found that users used different combination of factors when evaluating other apps. They may gradually consider more factors or ignore certain factors. It's an accumulating experience through the app space. And also in terms of the heuristics, we have created a new type of heuristics, which is return to the first heuristics, where users, after evaluating multiple apps, they came to the conclusion that the first view app is the best app to download. Thank you.
Thank you very much, Adel. And I'll just bring us over to the chat for the questions that we've got here. Now, what we'll do for the questions is I think we'll try and go through the questions for Brian's one first, and then we'll go back and we'll get yours, Adel. Although you can bring up your screen in case there's any questions that involve specific slides. Now, I guess the first question that we have is the question for Brian here. And the question is from Kat, and it's, why is identifying atrial fibrillation important in practice? So I guess what kinds of things can we identify if we can identify atrial fib or AFib?
Right. So it's the biggest thing I've seen is that it's been found to be empirically, I don't recall the physiological connection off the top of my head, but it's been found to be a precursor to a lot of other cardiovascular issues that are especially prevalent in patients who are already in emergency care or in the ICU. They're already more susceptible in general. I think I mentioned stroke, heart failure, and just general, a lot of other comorbidities, kind of a mixed bag. It's outside of the ICU in the general population, AFib is generally not found to be too problematic. But for whatever reason in the ICU, perhaps it's just the general condition of patients you see, it's more likely to cause other complications down the line. So if we can catch it early, perhaps we can also stave off things like the patient having a stroke later on. And we don't have to wait for them to, for example, have a stroke in order to intervene then and have to do a much more costly and much more dangerous intervention.
Excellent stuff. We also have a question from Amun asking, can you please explain more about your 10-second segmentation strategy? Is it possible to do this initial segmentation in an event-based manner?
Yes. So if I'm understanding this correctly, I think we already do it somewhat in an event-based manner in that we look at when the pre-trained models we're using to segment the data decides that the actual label has changed. So when the type of rhythm has changed. When you look at that in the context of AFib, if you have a signal that's normal rhythm and then it suddenly swaps over to AFib, that's kind of, I guess that counts as an event. The 10 seconds is more a limitation of having to choose a reasonable amount of data to actually feed to any model we're using or to give to a human, because they're not going to look through an hour. So once we have those segments, we just take the first 10 seconds, and under the assumption that if it's contiguous all the way through, that the first, like say if the segment's classified as all of AFib, then the first 10 seconds will also be AFib.
Okay, that makes sense. I've got a question from Arjun as well. I'm going to post it here in the chat. Arjun asks, he was wondering what type of machine learning model you're using. Is it a supervised model or an unsupervised model? What kind of a thing are you doing there?
Right. Oh, yeah, sorry, I didn't explain it on here, I think. So we're using two supervised convolutional, one-dimensional convolutional neural networks from the literature that have already been applied to ECG classification tasks, but outside of the ICU. So they're kind of pre-tested state-of-the-art models, so we didn't want to reinvent the wheel there. Eventually, we do want to look at using more unsupervised learning or weakly supervised, semi-supervised as well, because obviously there's a limit to the amount of label data we can create, even with bringing on a whole bunch of whole new batch of annotators, and we still have so much data to work with. So if we can incorporate some of that unlabeled data as well, that would be ideal.
That makes a lot of sense. Here we go. And I actually had a short question myself about you mentioned at one point that the classes that you have there that sometimes doctors have different ways of determining which class things belong to, and it doesn't even necessarily match up with the classes that other doctors use. How did that impact, I guess you talked a little bit about it in your presentation, but how exactly did that impact your choice of how to break this up into different categories, given that different doctors are doing different ones? Did you pick the most popular, or how did you do it?
So for the actual classes that we're using the annotator, of which are 8, we just consulted our clinicians. So one of my advisors is an ICU clinician, and some of our collaborators are as well. And they put up like a kind of taxonomy of different labels they think would be important to see for our data set. Try to normalize it with the 2 public data sets we used was difficult because, again, they had their own idea of what they were looking for, and they weren't necessarily looking for AFib. So at least the 2 classes that we have in common that we're most interested in are obviously the normal rhythm and the AFib class. The other classes get a little difficult. They're mostly there for reference if we ever want to look at them. But as long as we do have a AFib class, which everyone can mostly agree on what that looks like, it's pretty unambiguous. And a normal rhythm class, which is perhaps a little more contentious, but at least, everybody, there's a canonical normal sinus rhythm wave. Then we have a baseline to work off of. So it's not perfect, but at least for the purposes of, as long as we look at one data set at a time, it's not too difficult to work around either.
That makes sense. Here we go. Now I think that's all the questions we have for Brian, so I'll move over to Adel there. And we actually have a question for you from Robert. Robert mentions that as they become older and wiser, they find that they browse apps less and less because they have some concerns about privacy, and they're not trusting the apps as much. And they're wondering, do you think that privacy concerns will become more important to people when they're deciding to install apps in the future? How do you think that'll change?
I think it's the perception of the privacy. It's different from different users, and Google has been criticized from many years for the use of their permission systems, and they have changed that system a few years ago. And it turns out that you have to accept the permission beforehand. Like, for example, when I explained on my my framework, just a second, and it was difficult for users in general because it takes time to look for a reason or a justification. For example, if some of the permission for, let's say, an application, let's say for scanning receipts app, for example, or a flashlight app, for example, why they ask for a permission to access my calendar or my contacts? So some of the participants, for example, say they are presented, some of them most of the participants, they just skip because they don't have time. Either they don't understand them or they're hard to justify. And some of them, they check if they are reasonable. Even they've changed the permissions in the current system, it's still the categorization of the permissions is vague, it's not well constructed. And also you have to navigate through the App Store, scrolling down to see the permission details, which is difficult to understand. Some of them, they have an access to your serial number, and some of them have an access to your phone number as well. So the amount of information that's been accessed by apps are really questionable. So it's hard. Sometimes people relate to the use of permissions, to the privacy policy. When you install application, the agreement, you just accept. You don't have thing to do just by going to accept. I don't have much to do with that. If I'm not interested in the app, I'll just install it. And some of them, they prefer the paid apps instead of the free apps because it turns out to be less permissions. The free, it says there is nothing free in this nowadays. Everything has something in return. So I think it depends on the criteria of how users value or perceive the privacy in general. I hope this answers the questions.
I think that's a solid answer there. And Robert actually had a second question asking whether you think the Android's app space is too oversaturated for an aspiring new app designer with limited marketing capabilities. So is there a way for, I guess, is there any way that new apps can easily be discovered? Have you explored any data surrounding that?
In terms of, it's hard because the Google, like in general, you don't know the exact algorithm, how users, how they will present apps to users in general, because some of the participants stated, for example, Google put the top apps in the top. However, when you see like the ranking is different, 3.8 came first and 4.8 came at the end. And their website, they say we organize the list of application based on the rating and the reviews, but it's still not clear because some of the apps are presented in the top. So in order for them, maybe if a developer wants to develop an app, for example, they should look at the aesthetic design of the application, the pictures. For example, some of the participants stated that if I see a free on the app logo, I'm not going to use that because there is something wrong with this application. So maybe they pay certain attention to the design of the app logo, maybe considering the name. The name and the brand of the app is really an important part. Because if I see an app made by Google, oh, I'm going to go with that. Why I have to go with unknown brand or unknown app?
Excellent stuff. Let's see, we got the next one up here. We have a question from Catherine asking, in terms of looking at reviews as a queue, do false reviews have a big impact on this? Because obviously people have heard of companies posting a bunch of false reviews to try and boost their app. Is there a easy way for users to, or in general, do users have an easy time differentiating between the two?
It depends on the user. Sometimes some of the users, as I mentioned, of the few factors or the few cues, it's also related to our daily life. When we buy a product or something, sometimes some of the participants, they stated that they want to install multiple apps to compare. I want to try it firsthand instead of just going through a bunch of different information cues. And some of the participants were aware that they will consider looking at negative reviews with 1 star and 2 stars. They said that this is the true reviewers or who have their problem not been solved. But if I look at the 5-star reviews, maybe he said, one of the participants stated that maybe he is a friend of the developer, or maybe it's considered to be a fake reviews. But some of them, they just look at the negative and the positive reviews and they compare between the both until they maybe reach a saturation point when they consider that, oh, maybe I will give it a try. And some of them, they go through the reviews to see if there are any problems with maybe latest update or a bug or something like that before going to the application to install it.
Wonderful, and I think that answers our next question too, which was from Lucas about it was about the same thing. So I think you actually covered that in your answer there. I myself had a question about the slide that you're on right now, because I noticed that one thing that isn't on there is there's no path that leads to the user installing no app. And I'm wondering if that wasn't something you were interested in, if you were only interested in the people who are installing apps, or if it was just if it was a limitation of the way that it's designed.
It's some of the limitation because one of the participants indicated that because it's like a mock-up phone, they will install that. But when they saw the permissions, said, no, I'm not going to download this application. They have access to my files on the phone. They have access to my contacts. They have access to my calendar. They will know more information about me. So one of the participants stated that they will not install the application, for example, for the nutrition and health category because of the permissions. But I was looking at for example, let me see here. The path that the participant take, for example, after evaluating. So one of the participants started by looking at different factors at the beginning when starting smart receipts. They did not install the app. They went back, looked for another application. So they evaluate multiple apps. And after that, some of them, they consider, even with after returning to the first app, they consider different factors than in the first one. And some people, they said, no, the first time I viewed the app, the factors and the cues that I consider is enough. So it depends on the participant. And also one of the most important thing is that the individual differences. We value things differently. Maybe I see the reviews is important, but you can see maybe the app rating is important. So the views and the domain knowledge is hard to take account for, to examine these cues and information.
Excellent stuff. Well, that makes a lot of sense. And thank you very much. I think that covers all of our questions today. So now, before we go, I'd like to thank both of our presenters. And we have a video that we're going to be showing, actually. The Queen's School of Computing, one of our supporters, has some information about graduate studies that they'd like to share with you for any of you who are interested in potentially doing that kind of thing. We also have two representatives from Queen's, Debbie, the graduate program assistant for the School of Computing, and Aisha, the marketing communications coordinator. And they'll be here to answer any questions that you have after the video if you'd like any of that info. There you go. But thank you again for both of our presenters. Well done. And I'm just going to load up this video for you. Okay. Sorry for the delay, everybody. There we go.
That's a great question. I haven't had grad students for a while because I've been at a cancer center. So we didn't have a university to draw graduate students from. But what I've done since I've come to Queen's to pick graduate students is that, you always look for diversity of thought, diversity of background, to bring a group of people together that think differently about problems. We're an interdisciplinary group. We work with radiologists, pathologists, surgeons, oncologists, computer scientists, biostatisticians. So any background related to anything can really be usable in our group. We're interested in enthusiasm. We want people that are interested in curing cancer. We're not here necessarily to write another paper, although we're going to do that too. We're here to really move the bar on cancer care. We're here, we have a mission, and we are fulfilling that mission. And we fulfill that by doing these projects, but these projects and these theses are a microcosm of the whole system. We're here to generate new ideas and to really look at cancer in a different way. Students can have a variety of backgrounds. Some of the people that we work with are medical students or medical residents or fellows, but we also work with people that are computational students. We work with people that are from a basic science background that might have some basic science question that they want to ask of data that they might use computing to interrogate that solution. And we want all of those different types of people. And there's no one way to really pick those people. I was someone that was a good student, but I wasn't a stellar student, but because of my ability to talk to all kinds of different people, that's my skill set. And so I recognize versions of that in other people. Some people, want to work by themselves and work through a problem, and we love those people too. And then there's other people that don't work that way. And it really is just really about building a team that has a common mission.
So for graduate students, I think the most important thing is about this person should be self-motivated. So because I think passion is like the motivation for doing research. And the second thing that I hope she or she will have a high level of commitment. So that means they can take responsibility for their projects and knowing how to manage their time, how to communicate or collaborate with other members in the same team. The third aspect I would see is ability to think. So that means the person should have some understanding towards how research generally work. There is a like formal process or workflow to follow. He needs to know how to analyze the data, how to collect the data, and how to perform some general experiment. So that's also very important for graduate students. Last but not the least, if the students can have some experience, especially the research experience in the areas where are similar to mine, then I think it will be very good. So I would definitely think this person is very suitable for my research lab.
I think a very successful graduate student has two key properties. One is a drive and a passion to learn and discover. It's incumbent on a graduate student to discover things and push the envelope in what it is that we know and understand as part of their dissertation. And so this has to be a driving force for what it is that they're doing. And the other is a passion and drive to always improve and optimize their own process. And so trying to improve how they work and how they learn, and to always try and sort of reflect and introspect on what it is that they're doing there. I think this makes for very successful graduate students.
I think the most important quality is to be really passionate about science and research and to be able to work really hard on it. You need to really enjoy learning new skills and solving problems and make this your lifelong career. Another quality is good self-management in terms of both time and emotion. A typical day of a graduate student is often not very well structured, so you need to have good plans and to be more efficient. At the same time, research can be a very lonely process. You often have self-doubts, so it is also important to be persistent and to be able to make through.
It's great when people have relevant background in things like logic, mathematics, and programming. I think the most important quality is to be willing to work hard at things that don't come easily to you. No one is good at everything. Doing research involves being good enough at a lot of things. So if someone isn't a natural programmer or a natural writer, they have to work hard to do those things. And more generally, research is hard. It's about earning answers that we don't know yet. So you have to be able to persevere through things like having a paper rejected 5 times and then having it be accepted. Have people come up to you at the conference and say, well, this is fantastic. So you have to be able to work through the periods of bad luck until your luck changes.
Passion to innovate. So this is actually looking into this kind of strong urge to explore the unknown, try to advance our knowledge to be able to come up with technologies and solutions that can help improve human kind of activities and human lives and our kind of well-being in general. So once this is there, then actually this will actually make the process of having the other kind of skills such as perseverance, hard work, all these kind of things, they'll come naturally, but most importantly in a joyful manner. So I'm actually really interested in looking into students who will enjoy the ride.
First of all, like innovation and creativity. So it's the grad students that are interested in learning new things and that want to put the time to learn these new things. And also, what I'm really interested in is that the students and the grad students especially, they need to be very comfortable not knowing something and to challenge things such that they can push the envelopes of knowledge. And then you want them to be comfortable in not knowing, and but knowing the techniques of how to get there.
For me, the most important things are perseverance, hard working, motivations, and the determinations to finish. So doing research has a lot of fun. So especially at the beginning, we have tons of new ideas, new designs, brainstorm sections. But we need to put those ideas and design into action. conduct experiments and wrap them up into a paper, and the paper may get rejected for multiple times. And this process is difficult, and it takes time, and it requires hard working.
Excellent stuff. Wonderful stuff. Thank you, everyone, for joining us for that. And now I'm just going to get Aisha and Debbie unmuted so that they can answer any questions that we might have. And Adele, I'm not sure if you know how to unmute them. I think you might have to do it because you're the host.
Who am I unmuting?
There you go. Debbie Robertson. And then we've also got Aisha.
Of our time, I don't see a Debbie. Could they raise their hands so that I can find them?
Oh, there's
we go. Aisha. Okay. Allow to talk and allow to talk. There you go.
Wonderful. So if anyone has any questions about that, they're welcome to post them.
And we are coming to the end of this session and into the next one. So
there we go. And I know that both Debbie and Aisha will be available for several other sessions. I think especially during the poster presentations today. I think that they're going to be there, I believe, and we'll have the videos showing there as well. And also tomorrow at our first student presentation session, we'll be having another video to show.
We do have time now because the next session doesn't start till 1:15, and they're both able to speak if there are any questions. Looks like we're clear.
Well, if there are no questions, that's perfectly all right. If anyone does have any at any point, like I said, you'll have plenty of opportunities to ask them.
And there are no such thing as any stupid questions. Just wondering where everyone is coming from. If anybody would like to share that in the chat, be interested to know what areas you're coming from or what universities you're coming from.
Excellent, and even the sub areas of computer science, because I know or anyone or even if you're outside of computer science, there's lots of different kinds of departments and sub areas that people are in.
I'd also like to make a point. Most people do not know, but coming to grad school, you are funded. Master students receive $19,500 a year, and a PhD student would receive $21,500 a year minimum.
It's funny, I didn't know that until I was going into my grad studies, and then all of a sudden I go in and I'm being told, oh wait, I get paid for this.
It is, it's definitely a great transition into the working world. Certainly because you do feel like more of an employee. You're kind of in between being an employee and a student. At least that's how I felt when I did my master's as well. But yeah, I believe I felt the same way as you did, Alex, when I started my master's way back in the day. But yeah. Okay, so we have Michelle Dina from Computer Science Applied Linguistics background at Athabasca University in Alberta. Oh, that's great. Welcome.
Yeah. And I see Jeremy Banks has a question asking, is the funding that you get based on TA ships and RA ships?
Debbie, did you want to speak to that?
Yeah, the TA funding is additional funding on top of what we promise. And the RAs are now called a Graduate Research Assistant Fellowship, and they are T4A, so there's no tax deducted from that funding.
There we go. So we have Arjan in Computer Engineering at York University, Lassonde School of Engineering. We've also got David Adams, focusing in natural language processing at the University of Lethbridge. And Carly Ross is at computer science with a mathematics background at Athabasca University. I saw when I was looking at the list, we had several people attending from there. And Elizino is a computer science PhD student at the University of Lethbridge, Alberta, focusing on using AI for solving NLP problems, so more natural language processing, specifically text summarization. I know that's a particularly popular area right now because that's something that really almost everyone, every major company could use an automation in that kind of process. So I know natural language processing is a very, very hot area in AI right now in general. There we go. And I think we actually, way up here, we missed Robert, who's been one of the source of several of our questions today. He's from Calgary, Alberta, and he's currently in a Bachelor of Science Computer Science program in the 3rd year. There we go. And it looks like at Athabasca University as well.
Is anybody here at all interested in continuing on to do further studies and or graduate studies at all, or what's your next step? You're probably going to be hearing that a lot for those of you who are at least in 3rd year and 4th year.
Yeah, and that's one of the exciting things I think about conferences like this, where you get to see other students, what kind of research they're doing, and that can inspire you. Because one of the big things actually also that I didn't know when I was starting my master's research, I kind of thought that, you know, within a month of starting my master's, I'd have some sort of, I'd have some sort of thesis that I'd be working on, and the whole time I'd just be working on that. But really the first part of it, at least for me, was hammering out what areas of the more advanced parts of computer science am I really the most interested in, and what am I working on for that kind of stuff. And so that's one thing I think many people don't realize is often a year into your master's program is when you might figure out what your thesis is actually going to be.
And Alex, now that we're on the topic of that, would you mind sharing what your thesis is on, just to kind of give an idea?
Oh, absolutely. I'm studying artificial intelligence as well. Now, what I work on is a specific kind of problem called assignment problems. So these are problems where you have a set of agents or resources, and you have a set of tasks that you need to complete, and you need to assign these agents or resources to those tasks in the best possible way. And for those of you who have taken the mathematics courses in 2nd and 3rd year, you're probably familiar with that kind of problem. It's a hard problem in computer science. It's NP hard often, many of the versions of them. And so I'm focusing on using attention mechanisms, which I know were mentioned in yesterday's keynote, and I'm focusing on using those to try and deal with these problems.
Very cool.
So it's been a pretty exciting kind of thing, and it's a lot of applications in things like business operations research in business. If Amazon wants to send, figure out which processing facility should we be using for this versus for this other task, they're going to be using software like that. It looks like we do have a question from Elizino here asking, I understand motivation is key for a successful grad student. What if you lose motivation on the way because you realize that most proposed solutions do not actually work in practice and are often exaggerated? So
I can definitely speak to that. I think that communication is the key when you start to lose motivation. Communication between your supervisor, between your peers. Certainly that can be challenging, especially in a remote time or a time like this. But, I think just expressing those concerns and maybe even just taking a break from time to time. I remember when I was doing my thesis in my master's, there was a point where I felt really unmotivated, and I spoke with my supervisor, and we decided on a time that would be mutually beneficial for both of us, for me to just step back for a week or two and just work on other things related to my thesis and my master's, or even just spend time reading on your area. And, take a break, just doing things that you're interested in, because, that can help keep you motivated. So But yeah, certainly the key is communication and attending conferences such as these. That can certainly help you get more inspiration, more ideas. I hope that helps.
And I think to add on to that, I actually have a personal anecdote with that for the longest time when I was starting my research, I was working on a specific problem. And unfortunately, I can't talk about the specifics of the problem I'm under an NDA for that. But I was working on one particular problem, and after months and months and months of work, we finally had this whole system running, the whole AI model functioning there, and it didn't work. It just straight up the methodology, and the longer we got through it, the more we realized I don't know if this is actually going to work, and at the end it didn't. But that ended up being okay, because at the same time I realized I'd learned a lot from that, and I was able to start the next step of, okay, well, now I have this other, now that I've been doing this and I've been realizing why this isn't working, all of a sudden I have 15 different ideas of how I can approach this now. Whereas when I started, I was handed this idea, why don't you try this? And I just assumed that would be the best approach. But finding out that something doesn't work is often just as exciting as finding out something that does. It brings you all these new ideas, and you get to try something new. There we go. So yeah, we do actually have to wrap up so we can get ready for the next presentation. But thank you everyone for your questions and for attending, and we'll see you all in the next session, I suppose.